law of gravitation. So we are looking at F equals to G times the product of the mass over R square. So the force, because this is 2 point, we have to explain that the force is directly proportional to the product of masses, but inversely proportional to the square of separation. Okay, so when they ask you state the Newton law of gravitation and it has more than 1 point, you have to explain what the formula is all about. So the force is directly proportional to the product of the mass, means that m1 times m2, but is inversely proportional to the square of separation. Okay, then the next part, by reference to forces, explain why the orbit of the satellite is circular. When we are talking about circular orbit, we remember about the centripetal force. Okay, so the only way that it has a circular orbit is that the centripetal force actually hold it in places, so it will go in a circular path. Okay, obviously we know that in circular path the acceleration will go towards the center of the circle, so we will start from there. So to be in circular orbit, the gravitational force, so as we said just now, we need centripetal force. So who provides for the centripetal force? In this case, the gravitational force. Yeah, so the gravitational force needs to act perpendicular to the direction of motion. Providing centripetal force. So if we draw it, let's say the motion is going here, so the v going here, then the acceleration is always going to the center of the circle. Yeah, that is how an object can stay in a circular motion. Okay, so that is it. Next. Okay, use Newton law of gravitation to show that h and t are related by this expression, where g is the gravitational constant and a and b are constant that depends on the properties of the planet. Okay, so first thing first, Newton law of gravitation, and we have period here. Okay, so these are we will be talking about g mm over r square provide for centripetal force, in this case m omega square r. You can use m v square over r, doesn't matter, you will get the same result. And from here I cross out the mass, we are left with g m over r square equals to, as we know, omega is 2 pi over t. Okay, so if we substitute that, so we will get 2 pi over t square r. Why we need to change it? Because from the question they are in the form of 4p square and t square. Okay, so we need that. Now the rest would be cross multiplying. So we have r cubed equals to okay, r cube, right? Okay, r cube equals to gmt square over 4 pi square. Okay, now we have this. Okay, if we go back to this part, h is the where's the height? Just now we have height is okay. Height h is a height that the satellite is above the surface. So in this case, the h plus b, because it is similar to the form that we just got. So h plus b cubed, this equals to distance cubed. Distance from where? From the center of the planet. So if h is the height from the surface, then the b would be the radius of the planet. Okay, so from here we can know that b is radius of the planet. And we have what else? Oh, okay, here gmt square, but in the question is gat square. So the a would be mass of the planet. Okay, so that is for double I. Next, triple I, use the gradient and intercept of the line in figure 1.1 to determine the values for a and b. Give the units with your answers. Okay, so just now we know that a would be mass of the planet and b would be radius of the planet. First of all, I'll be using the gradient first. Okay, the gradient, we have the graph is a graph about t to h. Okay, so the gradient would be t. Okay, let's, before we go to gradient, let me show you the step by step. So we start from h plus b cubed equals to ga over 4 pi square times t square. Now if I want to find or look for the b, so the h plus b must be equals to cube root of ga over 4 pi square, and then the t must be in the form of 2 out of 3. Okay, now from here we can find that, oh okay, now to use the gradient, that would be, we have to manipulate it into t to the power of 2 over 3 over h plus b. Yeah, h plus b, that is equals to, yeah, if we see here, this we have to flip, yeah, so that would be cube root of 4 pi square over ga. Okay, now once we got in this form, we just need to use the data. Yeah, so let's say I'm using 1 to 80 and 360 here, and 12 to the power 12 times 10 to the power of 6. Sorry, yeah, 12 times 10 to the power of 6, correct. Now let's input that. The first one is 1280 minus 360 over 12 times 10 to the power of 6. Okay, that would be equals to cube root. Okay, maybe you will be asking why here we have h plus b, right? Why we only use the h? Where are the b? Okay, so let me show you. So when we are talking about that part, the 12 to the power times 10 to the power of 6, so we have b plus 0, which is the b, and this is the first part, and then the second part would be b plus 12 times 10 to the power of 6. Now, because we only want the difference, okay, so this is how I eliminate the b. Okay, so this. Yeah, this is why I get 12 times 10 to the power of 6. Yeah, it's not something like, oh, it suddenly disappeared the b, then I just use the 12 to the times 10 to the power of 6. Okay, then from there I get I just re-input this GA. Okay, now it would be 4.506 times 10 to the power of negative 13. Yeah, that equals to 4 pi square over GA. Okay, then from here I can get the GA, the A would be 6.67, which is the constant of gravity, times 10 to the power of negative 11 times 4.506 times 10 to the power of negative 13, which is the gradient that we got just now, divided by 4 pi square, sorry, my bad, because we have to we have to flip, sorry, my bad. So we start with 4 pi square first. Okay, 4 pi square, so over 6.67 negative 11 times 4.506 times 10 to the power of negative 13. So this is how I get 1.313 times 10 to the power of 24, or is equivalent to 1.3 times 10 to the power of 24. Okay, so A would be the, just now would be the kg, would be the mass of the planet. Okay, now let's go for B. The B, okay, if we input the B here, so the t to the power of 2 over 3 would be 360. So I'm using the intercept. Yeah, intercept means that we will be using this part. Yeah, 360 and 0. Okay, t to the power of 2 over 3 is 360, and the height would be 0. Okay, so we use 360 over h is 0, so 0 plus b is b, is equals to, just input everything, 4 pi square over g times a. The a we just now we got 1.3 times 10 to the power of 24. Okay, so the b would be 4.6 times 10 to 4.7, sorry, times 10 to the power of 6 meter. Okay, so the final answer for this is 1.3 times 10 to the power of 24. The unit would be kg, and 4.7 times 10 to the power of 6 unit meter. Okay, that is it for number 1.